Okay. So, yeah, where we were. Yeah, first of all, thank you very much for the feedback. I received more than 60 feedback. So, based on the feedback I received, I had categorized your comments into different categories. So, one of the feedback that some of you have requested or like provided was to do more coding example. I'm going to do that, and then most of you have requested more time to complete the coding sessions, so I'm going to do that as well. And some of you have requested more information regarding the mini project. Okay, so this one, let me first share the presentation. I'm going to post the record. I was thinking of posting the recording so that those who don't attend the lectures cannot hear. I mean, some of you have gone to the leadership program, so I'll keep the recording on. So, project. Can you see the slides?
Yes, sir.
Okay. So, none of you have turned on the video, right? So all of you are facing power issues. So what's the situation over there? Hello. Can you hear me?
Yes, sir.
Yeah. So what's the situation in your area? The power outages. So uh, yes, person said the power. What about the others? Are you also facing power outages? Can I at least please get some response?
Yes, sir, there is power.
I prefer if you can speak out. Raise your hands if you are facing any power outages. Okay, how many? Um, okay, almost all. More than half having power issues. Okay. Anyhow, okay, so let's just continue as it is. So regarding the mini project, I received a couple of comments asking for more information. Can you please say what exactly do you want to know? What are the issues you are facing? I really appreciate if someone can speak out and say what is the issue that what do you want from me? What do you want me to explain? Otherwise, I'm going to skip this so that you'll have to do it on your own. No any issues with the project? It's like talking to a dead room. So can someone please speak? Because there were a lot of comments regarding the mini project asking for more information. I'm not sure what exactly you want. Saranga, can you hear me?
Yes, sir, we can hear you.
So can Do you have any concerns regarding the mini project? Because the feedback was anonymous, I don't know who exactly requested for more information. So please, can you, those who requested, can you please tell me what exactly do you need help with? The report, the proposal, or the title? What exactly it is? Anthony, do you have any comments regarding the mini project? Any questions? Okay, if you don't have any, I'm just going to skip this. So let's go to the lesson. Okay. Being engineering students, at least you should be able to ask questions, right? I mean, I'm surprised that no one raised their voices to ask questions. At least even not in the chat. So it's you are lost. I mean, I was planning on explaining the mini project in detail, how to write the report and all, if you had asked the question. So apparently you don't have any questions. So let's go to the lesson. So we think last time we discussed insert related to single linked list. We discussed the insert operation, couple of insert operations. Today we will start from delete. So today we're going to start with delete operation. Delete wise also we have three options as in link insert operation. We can delete the first element, we can delete the last element, and we can delete the middle element. Okay, so yeah, so let's start with deleting the first element. So as you can see here, deleting the first element is about if we have the linked list like this. So here they have a linked list with 4 elements. So we want to delete this one, right? So the head, delete the first node of the link. So start with the signature of the function. First thing we have to do again, we need to check whether the list is empty. I think I told you a couple of ways to check how the list is empty. One is to see whether the head pointer is exactly null. Can someone tell me another way of checking whether the list is empty?
Check whether the tail is null.
I'm sorry.
Check whether the tail is null.
Oh, yeah, that's correct. Yeah, so tail is null, and another way is checking whether the size is exactly equal 0, right? So if the list is empty, we can't delete anything, so we'll just have to output a message saying the list is empty. And if the list is not empty, so how we're going to delete is I think it's quite similar to the insert operation. Yeah, so one and if the list is not empty, another thing we need to check is whether the list only contain one node, right? So so that we can do by just checking the size exactly equal 1 or not. So if there is only one element, then the size over here Yes. Yeah, size over here is 1, right? So if the size over is exactly 1, so that means there's only one element. So in that case, how the linked list look like is there's only one element and the next pointer is null. This element will be both head and tail, right? So so what we're going to do is we're going to create another pointer, say temp, and we are going to link it to head. We are going to point to the head node, and if the linked list size is exactly 1, that means we're going to have to delete this element, right? So once we delete this, this node, once we delete this node, both head and tail should be null, right? So we basically, what we're going to do is we'll delete. If you remember how to delete the pointer is, we delete using the delete operation. We delete the temp pointer, and then we're gonna assign both head and tail to null. And there needs to be one more step. What is it? What should we do? We are missing one more step. Morapitia 3672. Can you please answer? What is the missing step?
Decrease the size.
I'm sorry.
Decrease the size.
Yeah, exactly. Yeah. Voices are very low. Let me increase the volume. Yeah, the missing step is we need to decrement the size, right? So that we will do later outside the first loop. So now the next thing is what if the size is not exactly 1? That means we have more element, as in this example, right? So this example it depicts that there are 4 nodes, and we will have to delete the first node. So how do we do that is so how do we do that is so we have the head over here, right? So we have the head point over here, right? This one, which was pointing to this node initially. So what we're going to do is we are going to redirect the head to the next node, right? And we already created a pointer for the head node, which is for this one, using the temp variable. So now temp is pointing to this one. Now we moved the head to the second node. Now we need to delete the temp, right? That means we need to delete this one, right? So we basically delete temp, and the last step is decrementing the size. Is this clear?
Yes, sir.
Okay. Good. So okay, this is clear. Let's go to the next function, which is to delete the last element. Okay. So I'll do the coding examples. I'll first explain these functions, and then we'll go to the coding example. So the next function is deleting the last node. So similarly, so let's start with the basics. We have the methods, the function signature over here, and we first check whether the list is empty. If the list is empty, we can't do anything, and if not, now because we are deleting the last node, earlier we went with the head, Now we have to go with the tail, right? So we're gonna take now because we are deleting the tail node element, right? So this is what we are deleting, right? So we take we assign a pointer to tail. So that means what we have done over here is we created the temp pointer and we have assigned it to this node. So the temp pointer is pointing to this last node now. So the same thing we have to do, check whether the size is exactly 1. That means there's only one node. So we'll delete that and we'll assign both head and tail to null. And now if all the if it is not all these cases, that means we have a list with a couple of nodes, right? So we'll have to now we want to delete the last node. So in order to delete the last node, so what we have to do is we have to take another pointer called current, and so we start the current with the we start the current pointer with head. So we start the current pointer assigning to the head. That means the current pointer when first created was pointing to the head, and we loop or we shift this current pointer until it reaches one node before the tail. So how we check that is, how do we check that? Check using size minus 2, right? Size minus 2. Right. So size minus 2 is let me give you explain this using example. Let's say we have a list with 1, 2, 3, 4, 5. So we have a list with 5 nodes. Okay, the last one is pointing to null. All right, so we have a list with 5 nodes. Now size is, what's the size of this list? Size is 5, right? So 5 minus 2 means 3. So let's see where it's going to. So we start with the current over here, and in the first loop. So okay, I forgot to mention this. So how do we go from one node to another? Is we basically equal the current to current dot next. So in the first iteration, we jump to the next node, the second node, and so at that point, I is still 0. I goes over here. I comes over here and comes over here. So at that point, so after that I becomes 1, and then we jumped again, right? So jump again. So I is 1. I still less than 3, right? 1 is less than 3. Size minus 2 is 3, right? And we do a jump, and I comes over back over here. 1 becomes 2. 2 is still less than 3, so we jump another one, and then I comes over here. 2 becomes 3. Now 3 is not less than 3, right? So that means we stop over here. So where the current ends up is over here. So correct. So 1, 0, 1, 2, 3. Correct. Is that clear? How current ends up one node before the last element, last node?
Yes, sir.
Okay. So now we have the current over here. Current is over here, right? So current is over here. Next thing we need to do is similar to what we did with the first deleting the first element. So we move the tail to the current, right? So now tail is equal. Yeah, so we move the tail to current. So now the tail is equal to current. That means tail is now pointing to this node, right? Correct. And then tail dot next. So now tail is over here, right? Now tail is over here. Tail dot next, that means this one, we assign it to null. So basically null, right? So now it's null. Still the temp is there. Temp is now pointing to this last node, even though we broke this connection and we basically assign the next point of the this node to null. The temp, this temp is there, so we need to delete that. So we delete temp. Then how do we delete a pointer? Is using the delete keyword, delete temp, and then we decrement the size. Is this clear? Any questions on this? Deleting the last node? Please raise hands or just give. So could you explain the follow in delete last function again? Okay, do you mean okay, this one, right? So this, let me take another. So this follow, okay, so this follow is to move the current pointer from head to one node before the tail. So that's the purpose of the current pointer. Otherwise, if we don't have a pointer pointing to this node, we can't shift the tail over here, right? Because this is a singly linked list. There's only one link, that is also to the forward side. There's no link to backward side. So we can't move this tail pointer from here to here if we don't have a pointer pointing to this node. So the purpose of using the for loop is that. So how it works is, if I explain again, how it works is, so we start with current pointing to head. I'll draw again. So start with, we have 2, 3, 4, 5. Can't we directly point the temp pointer? Lakshan, can you please elaborate?
So I mean that in here, in the second else part, you create a new pointer as current, which is point to the head node. Yes,
Yeah.
that can't be pointed to the tail and delete it.
Yeah, we can, but how do we go backward? Because this is singly linked list. So yeah, we can create a pointer current and assign it to tail, as you said. But how do we move from tail to over here? So we somehow need to go to this node, right? So that's the issue. We can do that with the doubly linked list. So we'll be learning that next. With doubly linked list, we can go from here to here. With singly linked list, only way that we can go is from start to end, right? So if we start from here, so we can only go in this direction. We can't go back because there is no link from. So if you remember linked list, when I started linked list, I mentioned the main feature of linked list is that there is a link from this node to this node. From A to B, there is a link. So we can move from A to B. However, we can't move from B to A with singly linked list because there is no link to backward side, right? Whereas in doubly linked list, there is a link from B to A as well. So that's possible. So what you suggested is good and is possible with the doubly linked list, because there are links to both sides. Whereas with singly, it's not there. So we'll have to start from the current. We'll have to start current from the head and moves all the way until one node before tail. I mean tail minus 1, right? Is that clear, Lakshan?
Yes, sir.
Okay. So with that, let's move to the next function which is deleting a node at a given position, right? Yeah, so for that also we're gonna do a similar thing as we deleted the last node. We will have to have a current pointer starting from the head, and we'll have to move the current pointer one node up. So that means if we are deleting this one, we'll have to move the current pointer until over here. There's a couple of additional things that we need to do. So that those are, one thing is we need to first check whether the given position, right over here, this position is a valid position. That means, so in this example, our linked list is of size 4, right? Our linked list is of size 4. So whatever the position that we are given, so our elements nodes are 0, 1, 2, 3, right? So what we can delete is one of these nodes. So we can't delete any node that has a value that has an index -1 or anything that is below 0. We can't delete, right? That's not a valid position. So we'll have to check that. So how do we check is we check whether position is lower than 0, right? So that's how we check it. And yeah, so that's how we check that side. And the other part is we need to check whether our position is whether the given position is higher than or equal to size. Why this equal sign? Can someone explain why equal sign? Chandrasekhar, 3548. Can you please explain why it's equal? Why it is not just position higher than size? Yes, Chandrasekhar. Any comments? Can you hear me, Chandrasekhar? Can you hear me? I see that you have unmuted your mic. Can you please say whether you can hear me or not? It's very hard to do the lecture if you don't cooperate. I mean, I don't want to forcefully induce this knowledge on you. So you have to cooperate, right? So if you can hear me, why can't you speak? Chandrasekhar. Can others hear him, or is just only me?
No, sir, we also can't hear. His mic is unmuted, sir.
Yes, his mic is unmuted. Okay. So I think someone gave me the answer in the chat. So yeah, so why equal sign is so our size is 4, right? So our size is 4, but there is no node with the index 4 because we are starting our indexes with 0. So there is no node with the index 4. The highest node that we have is size -1, that is with the index 3, right? So that's why this equal sign is there. So if we are asked to delete a node with the index 4, we can't do that. So that's why we have to check whether the given position is greater or equal than size. Okay. So if not the case, we have to output and say that there's invalid position. Okay. The next thing is this is actually similar to insert operation. Now we have already implemented the codes for at least I have teach you how to implement the codes for deleting the first node, deleting the last node, right? So we can use these methods. So if the given position is exactly 0, that means they are asking, or he or she is asking us to delete the first element. So we can directly use the method that we implemented earlier, which is delete first. So the next thing is if the given position is exactly equal to size minus one. So here in this case, they are asking us to delete the tail node. So we can use the method that we created, which is delete last. And now we come to the part where we have to implement. So they are asking us to delete the node that is of intermediate. So for example, they are asking us to delete the second node, right? Okay. So how do we do that is we follow this similar procedure. We start with the current node, which is pointing to head. That means, so we create a current, sorry, not a node, current pointer, which is pointing to the head, and then we shift, right? We shift a step that is equivalent to position minus 1. Now in this example, let's say the position that is given to us was 2, right? Position given to us was 2. So 2 minus 1 is equal to 1. So how many shifts are we making? So we start with 0. So when I is equal 0, current is over here, right? Right. So we start with over here. I is equal 0, we jump. When I is equal to 0, we make a jump, and then we increment the I, and when it comes to over here, I is 1, we do another jump. So now the current pointer is over here, right? So the current pointer is over here, and I is 1. Did I mess it up? Did I mess it up? So let me check. Yeah, so I messed it up. So we don't do another jump, right? So what we want to do is we want the current pointer to be here, right? Because we are deleting this node, the current pointer needs to be one node before, right? One node up. So I messed it up. So with I equals 0, we do the jump, and then I becomes 1, right? After the jump, I becomes 1. I becomes 1. So because 1 is not lower than 1, so that means this break is going to this loop is going to break. So we end up with current pointer over here. Is that correct? This won't be there. Let me delete them. We don't do another jump. Okay. So we end up with current point over here, and the next steps are quite straightforward, right? So similar to what we have done with the delete in the last node. So we take a temp. So we create a temp. Let me first write it down. We create a temp variable, and the temp variable should be pointing to this one, right? Now, can someone tell me how do we assign the temp pointer? How do we create the temp pointer? Anybody? So what we have up to now is we have a current pointer which is pointing to this node, right? How do we create? Now we want a temp pointer which is pointing to this node. How do we do that?
Equating the temp to the next of the current.
Can you please repeat? Because of the generator, I can't hear properly.
Equating the temp value to the next of the current.
Yes, correct. Good. So yeah, what we do is we take the current dot next and we assign it to temp, right? This part is not there. So yeah, that's the first thing. So now the temp pointer is pointing to this node. All right. So the next step is now we need to break this. So we need to break this link, or not break is not the best word. Better word is we need to assign this link to this guy, right? Because now we are going to delete this node next. So we need to change this link and assign it to this guy. So how do we do that? Any answers? Fernando 3585.
Current dot next equal temp dot next.
Can you please repeat?
Current dot next equal
Yeah,
temp dot next.
exactly. Good. Yeah. So how do we do that? Is current dot next equal, so current dot next is this link, right? This link is equal to temp dot next, right? Now temp is this one, temp dot next is this one, right? So we basically equating, we are assigning this one, this link to whoever that is pointing with this one. So that means this node. So we assign the current dot next, that is this link, we assign to temp dot next. That means we are basically assigning it to this node, right? Clear? So we have now broken this link, right? So, and let me take another color. Yeah, so we have broken this link and we have assigned it to this one, right? So what is left for us to do now is we just need to delete this. So how do we delete? Delete temp. Correct? So those are the steps involved. Let's see. Yeah, so we create the temp with current.next. That means this step, right? The next step is shifting the links. So current.next is temp.next equal to temp.next, and then we delete and decrement the size. Right? Is that clear? Any questions? Is this clear?
Yes.
Oh, so the time now. We have 15 minutes more. Um, okay, I'll teach you another function, and then let's go to the coding after that. So the next function I want to teach you is search. Actually, with linked list, there are many functions you can create. I mean, there are many functions available. You can create more functions according to your requirements. So I'm just going to teach you only the basics. On the two most important functions are deleting and inserting, and after that we have search functions. So here what we are going to do is, so we are going to search the linked list by a given element, right? So search for the nodes with the given value or element. So how do we do that is, now I believe you are clear on how to search, because I have already, or at least you should be clear on how to move from head to the tail, right? Because we have done that with two delete operations. So how do we move from head to the tail is, we first create a pointer and assign it to, I mean, we basically point it to the head, and then so okay, and then we create a for loop. We start with I equals 0 and we go until size. That means we are going from first node to the last node, and while we move, so I explain again, so what we are doing is we start our current from over here, right? Current is over here, head is over here, tail is over here. This is now. Okay, so we start by pointing current to the head, and in each loop, in each iteration we move the current from head to the tail. So while we do that, now we need to check whether the element inside. So each node consists of two things, right? One is the link, the other one is the element or the value. The value is there over this side, right? In each node there is a value, right? So now what we need to do is we need to check whether, while we shift from head to tail, we need to check whether the value inside each node is equal to the given value. So if it is equal, so how do we check, how do we access the value? Is using current dot element, right? If you remember, each node consists of two things. One is the link, other one is the value. We define it by element. So how do we access this? Current dot element. So if current dot element is exactly equal to the given element is coming from over here, right? The input. So then couple of things we can say we can do in this example. We are just printing the indexes of those nodes, correct? So we are printing I is the index, right? So start with I equals 0. We print the indexes of those nodes in this example, and so this is how we shift, right? So this is how we shift. Yeah, so that's pretty much it. Is it clear? The search function, is it clear? Do I need to explain it again? If you cannot speak, at least type it in the chat. Do you want me to explain it again? Search operation. Anybody? Anybody? Amarbandhu, 3528.
Yes, sir.
Clear?
Yes, sir. Okay.
No. So yeah, with this, I'm going to give you the first assignment. Actually, this is only a part of the assignment, because now you have 3 assignments, right? If you remember, you have 3 assignments. Okay, there was another comment. Or you want me to explain it again? Okay, what we're going to do is I'll explain that using codes, right? So then you'll understand it better. So before going into codes, let me give you your first assignment, a part of the assignment. So you have 3 assignments, and out of the 3, I'll be giving you 1.5. So the first assignment, everything is from me, and the second part of the second assignment will be from me, and that means from data structures, and the remaining parts will be given by Mr. Nilmant from algorithms. Okay, the first assignment is write a function to search and delete nodes with the given element in a singly linked list. All right. So I explained both delete operation and search operation. Now you need to combine those two and write a method or function that searches search a list and delete the nodes with a given element, right? Clear? So you need to search the list, and at the same time, if you find a node that has the element, you need to delete that. Okay. Make sure you need to code from the scratch. That means no any previously coded functions such as delete first, delete last should not be used, right? So delete right from the scratch, and if you use such functions, marks will be deducted appropriately. And this is one of the important things. Any plagiarized code if you copy it from someone else and or even from the internet, you will be given 0 marks. So don't take that chance. So there are tools to check whether you have copied from others or even from the internet. So a couple of tools I have used is Authenticate and Turnitin. So these are the most popular tools to check whether you have copied from someone or copied from the internet. So I'll be doing the checks. So I'll be using Authenticate and Turnitin, one of those probably, to see whether you have copied. So don't take the chance. It's not very hard. Try to do it by yourself. Then only you will get to know, I mean, the lessons better, right? So if I explain it again, so what you need to do is what the function you need to do is, for example, let's say your linked list is this one. You have created a linked list like this. So the head node is 5, the second node is 4, the next node is 5 again, the next node is 5, the next one is 8, the next one is 2, and the last one, or the tail, is 5. This is your linked list. For example, you have created a linked list like this. Now, if your method or the function needs to be with this signature, it needs to have this signature delete with, and the input should be, there should be an input which you're going to match out with the nodes. So in this example, what you have asked is to delete nodes with a value of 5, correct? So in this linked list, there are a couple of nodes. These 4. There are 4 nodes with the value of 5, and you need to delete all. And your last or the output linked list should be something like this: 482. So is that clear? So you need to submit both the singly linked list class file and also the main file. You need to create a main file, main method, and try out with different examples or test cases. Try out, create a linked list, input some data or input some nodes, and then try the delete function that you create, that you're going to be creating, and see whether you are getting the correct output, right? And so you need to submit both files, the class file and the main file. I'll give you one hint, as it says here. Try to use 2 pointers. Now, up to now, we have used only 1 pointer, which is current, right? We start the current with head, and then we shift it until the head or the required position, and then do the task, right? Now, for this, try to use 2 pointers, current and previous. So what's going to happen is, I think I'm basically giving it away. So anyhow, so what you need to do is, if your current is over here, your previous should be over here. So if you do it like this, you can implement, or you can delete all the nodes with a given value in one round. So you just start from here, you go until the tail. In one round, you can delete all the nodes. That would be the perfect code. It doesn't matter. I mean, it doesn't have to be like that. You can do it as you like and as you see fit. But the perfect case is you start from here, the head, and you go until the tail in one route. And while you shift, you need to delete. It's better if you can delete all the nodes that matches the given value. Is this clear? Any questions? Please ask now, because you may not have time to complete like by next. I'm planning on asking you to submit this. I'll give you the date later. It won't be. You won't have much time. Probably you'll have to submit before the new year. So please ask if you have any questions now. So if you wait until next week, you won't have enough time. So please ask if you have any questions now. No questions? Yes, it means your code should have only one function, delete with, yes. So inside this function, you need to write everything. Any other questions?
So can we have other functions to delete the, to insert and for the test case?
Yeah, for the insert, yes, because see, the insert part comes in the main file, right? The main, under the main method. Now, what I meant by you can't use any other function is you can't any other functions inside this one. So this function you need to write it from the scratch. Delete with, you need to write from the scratch, right? Whereas inside the main, or even I mean inside the single linked list class, so insert, right, you'll be basically needing insert, right? The 3 different versions of insert, you'll be needing them, so you can use them. I mean, you can just copy what I have done, you can copy them and you can use them. Whereas this delete with, you need to write it from the scratch. Is that clear? Who asked the question?
Yes, sir.
Okay. Anything else? So now let's go to the coding. Thing. Yeah, before going to W linked list, let's go to the codes and implement this. So while I prepare the go to the Visual Studio. So if you have any question, please ask. Can you see the Visual Studio screen?
Yes, sir.
Okay. Yeah. So what we need to do, or what we're going to do now is we're going to implement the delete 3 versions of delete. Let's start with, you can do it with me. I'll give you some time as well. Delete first. Let's start with delete first. Okay. So if you remember, what first what we need to do is we first need to check whether the given list is empty or not, right? So how do we do that? Is couple of ways. One is checking whether the head is exactly null, or we can also do it by checking whether the tail is exactly null, or we can also do it by using the size variable. So we need to check whether the size is exactly 0, right? Yeah, so if the list is not empty, so the next thing we need to do is, if you remember, so we first need to create a pointer and point it to the head, right? And then we need to check whether the size is 1. So if the size is 1, that means our linked list only consists of 1 node. So in that case, what we need to do is we can directly delete the node or the pointer pointing to that node. And then we need to assign both tail and head to null. Assign null, right? And then you need to decrement the size. Is that clear? So if the size is exactly not equal to 1, that means there is the link with couple of nodes, right? So if you remember, what we need to do is, let me go to delete first and show you. So if you remember, what we need to do is, we need to shift the head to the next node, right? We need to shift the head to the next node and then delete the temp, right? So how do we then do that is we shift the head to next, right? So we basically shift the head to the next node and then delete temp and determine the size. Is this clear? I'll give you 1 or 2 minutes, maybe 1 minute to implement. Okay, have you all done this? Have you implemented the delete first function? Do you want more time? Anybody? Please raise hand if you want more time. No one? Okay. So we're gonna go with the next function, which is void delete last, right? So sorry, I was disconnected. Can you hear me? Hello, can you hear me? Am I audible?
Yes, sir.
Okay. So the first thing, okay, I need to share, right? So let me share. The first thing we need to do again is to see whether the list is empty. So do that by checking whether the head is exactly equal to null. Else, we create a pointer temp. Now we are pointing to the tail. Earlier we pointed to the head, right? So we are now pointing into the tail. Pretty much same thing we need to do. First check whether the size is 1. That means the list is list only contain 1 node. So if it is only 1 node, we delete the temp. We point both head and tail to null and decrement the size, right? Give me a couple of minutes. There's some interruption with the internet connection. So meanwhile, you can go for a water break. So give me a minute to clear this up. Am I audible? And can you see the screen? So the internet connection is not stable. So can you see the screen now? And am I audible?
Yes, sir.
Okay. Okay, let's go back to where we left off. So yeah, we were in implementing the delete last function. So well, if we come to else part, that means there's a list with couple of nodes, and we want to delete the last node of that list. So the first thing we need to do, if you remember, we need to create a current pointer and point it to the head, and then we need to shift it, right? Shift it until how much? Size -2, right? How do we shift is current equal current dot next, correct? So we shift it until it reaches the node which is right before the tail node, right? So if I go to the presentation and if I show it to you, so yeah, if you're here, so we shift the current pointer from head all the way until to a node which is right before the tail, right? And then what we need to do is yeah, so what we need to do is, if you remember, so the first thing we need to do is we need to shift the tail to the current pointer, right? So we're going to shift the tail to the current. So here we shift the tail to the current, and then now the tail is over here, and the tail dot next we point it to null. So we are basically creating this link, and then we're going to delete the temp, right? So the first thing, tail should go to the current, and now the tail is right before the last node. Tail dot next should be null, right? And then finally delete the temp and decrement the size by 1. Any questions? Is this understood? Any comments? If you don't understand, please at least tell me in the chat so that I'll explain again. Ganegoda 3588. Is this understood? Is this clear for you?
Yes, sir, it is clear, sir.
Clear, right? I'm sorry, I can't hear you.
Yes, sir.
Yeah, okay. Okay, so this delete last. So the next function we need to do is void delete at, and the input is position, right? Okay, so the first thing, what is the first thing we need to do? Can anybody answer? Uh, 3531. What are we doing now?
Yes, sir.
What is the first thing we need to do?
Check whether the position is correct.
Yeah, correct. So we first need to check whether the given position is within the,
It's within the range.
yeah, correct. So that's the first thing. The next one is we're gonna check whether the given position is exactly equal to 0. That means what do we have to do now? Gunatilaka 3592. If the position is exactly equal to 0, that means what do we need to do now?
We have to use delete first.
Yeah. So the user is asking us to delete the first node, right? So we can use the delete first function that we created. And if the position is exactly equal to what should be here, if the user is asking us to delete the last node, what should we check here? Jayakodi 3609. What should be the condition over here?
Position size -1.
Yes, I think I explained, right? So we need to check the position is exactly equal to size -1. That means user is asking us to delete the last node. Okay, if it is not the case, that means we are going to the else. That means the user is asking us to delete a node that is of an intermediate node. So how we do that is we create a current pointer, start with the head, and G1 3616. What should we do next?
I check the I equals position -1.
Yeah, so by doing that, what are we doing? I mean, can you explain what this for loop is about? What's the function of this for loop? What it does?
Current pointer is making current pointer is next to the position.
Yeah, so once this for loop is executed, what will happen? What explain me what is happening inside this for loop? Explain in one line. So what are we doing over here? This for loop, what does it do? Maybe someone else 3607 Surand.
We are trying to get the previous node.
Yes, so we are basically shifting the current pointer from the head until the position -1. That means the current pointer will shift and will stop at a node which is right before the node that the user is asking us to delete, right? So once it stop over there, yeah, so once it stop over there, the next thing is, let me show you with the over here. So the next thing we need to do now, the current point is over here, right? The current point is over here. So what we need to do next is we need to divert or redirect this link from current point from over here to this this node, right? We basically need to skip this node. So user is asking us to delete this one. So we need to redirect this link from over here to over here. Can someone tell me how do we do that? Leonage 3655.
There is a creator, not template.
Yeah. Yeah. So I forgot. Yeah, we are correct. So for the first thing we need to do is we need to create a current pointer and point it to the node that we need to delete, right? So how do we do that? We create a temp and we point it to the current dot next. That's where we are going to be. That's the node that we are going to be deleting, right? So the next thing is what I explained. So we need to redirect that link, right? So let me annotate. I'm trying to explain this to the fullest level that I can. So I expect some cooperation from you. So I'm explaining this again and again. So if anybody is not understanding, so that they can understand. So so current is over here, right? So now the temp is over here, right? So we created a temp pointer and we directed it to the current dot next, right? So the next thing we need to do, we need to redirect this link from over here to over here. So 3647 Kumara City. Can you tell me how do we code that?
The code point next equal to temp dot next.
Come again, sorry.
Current dot next
Next.
equal to
Yeah.
temp dot next.
Yeah, good. Yeah, so that's how we redirect. And the last step is, can someone tell me, okay, there's another way to do this. Might be tricky, but can someone tell me how to do this, the same thing, with only using the current pointer, without using the temp pointer? Can someone tell me how do we redirect this link from over here to over here? I'm not going to name because this is a little bit tricky. Can someone, if you have understood this correctly, the operation should be able to answer this. So what we want to do is we want to move this link from over here to over here. So how do we do that using only the current pointer? Anybody?
So calling current dot next twice.
Yes, good. So current dot next, that is the one that we want to shift, right? So current dot next, that is this one. Current dot next is this one. So we want to link it to current dot. At the moment, current dot next is this guy, right? The one that we are going to delete. So if we, so now this part is, so current dot next is this guy. So the next link of that guy, that means current dot next, that means this guy, right? So next, if we take the next of that, that means the last, this node, right? So we can do it like that. So current dot next, current dot next is this one. So we're going to equate it to current dot next. Is that clear? Anybody having questions with that? I hope not, because there's no question. So last thing we need to do, delete the temp and decrease the size. Any questions? Questions? Okay. If you don't have any, let's do the last method, which is the search. We are going to search the linked list for a given element, and then we're going to print him, right? So this one, right? Yeah. So we need to do is, so we are gonna go from the head to the tail. So we're gonna create a pointer and point it to head, and then we're gonna need a for loop. All right, so we're gonna shift from the head to the last one. How do we shift this? Current equal current dot next, right? So that's how we shift. While we shift, we need to check whether the current dot element, how do we access the element of the particular node is current dot element, right? Is exactly equal to the given element. So this element is coming from over here. Let's just say val or value, the given value, right? If it's the case, let's print it out. let's print out the index. How do we access the index? Is using I, right? So I equals 0 means we are at the 0th element, that right? So let's print it out. And let's just have another cout over here that says positions of the nodes with value. Well, so then the cout and new line. Is this clear? So what we have done over here is we have created the current pointer. We have started it from the head, and in each iteration we shift a node, and it goes until a size -1. What is this just effectively does is it will go from 0 to size -1, right? And in each iteration we are going to check the value of or element of that node is exactly to the equal to the given value, and if it is so, we're going to print out the index, right? So hope this is clear. The person who asked me to explain this, is this clear now?
Yes, sir.
Is it clear?
Yes, sir.
Okay, good. So I think we have implemented everything. What we need to do now is let's just try to call this function and see whether it's working. So these are some method, some function that I have created using the insert operation which you already discussed last time. Let me first run this and see the linked list that will be created, and after that we'll access the delete operations. Okay, so the last list that is created is this one. So we don't need these prints. So let's just ignore these prints. So this one, this is the list that has been created. The head node is 23, then 78, 10, 5, 45, 9, 12, 7. So that's the list created. So let's try to delete some. Okay. So let's first delete the first element, and let's print it. See whether it's working. So delete first. All right. Let's see whether it's working. Okay, so yeah, it's working, right? So that this was the list. It was created earlier, and when we delete the first node, now we have the list without the 23 node. So this is the list we have now. Let's now delete the last element and see whether it's working. Print method I already explained last time, so I'm not going to do that again. Yeah, so now the 7 is gone, right? So we deleted the last element. Let's now delete this one, 0, 1, 2, 3. Let's delete. Delete at the index was 3, right? Yeah, index was 3. So then let's print. Yeah. So now this node 0, 1, 2, 3. The third node was gone. Is gone. This is the final list we have now. Is it clear? Any questions before we go into doubly linked list? Any question? So the feedback I received, you can type in the chat if you have any questions. So I think the feedback I received, yeah, I'll show you. These are the feedback I received. You can see, right? So do more coding examples, provide a little bit of time to complete coding. The mini project. So no one asked, so that I skipped that. This one I don't think I have time to do that. So the codes I have already uploaded now. So as per your feedback, I have uploaded the codes that, I mean, codes from the array, 2D arrays, memory, heap, and stack. Already I have uploaded to the LMS. So some of you had asked for tutorials. So this is what I'm going to do. There was a tutorial from Dr. Raj who did this course previously. So I'm going to put that tutorial on the LMS, and you can try them out and check with me if you have any questions. So if you cannot figure out the questions, if you don't know how to do it, you can check with me, right? You can directly mail me, or you can put the questions on the forum in LMS. Both options are fine. Then we can discuss. So YouTube playlist, someone had asked for a YouTube playlist. So that I actually gave you a playlist in the first slide, right? So in the first PPT presentation, there is a link for a playlist, and I have already uploaded some tutorial list on C++ into the LMS. So both are there, so you can check them out. Yeah, so there was some comments regarding, they were asking some practical questions. They wanted, some of you wanted to try out some code. So that's why I actually gave you the assignment. So you can try that out as well. So I'm going to give you more examples, more codes as well while we move on. Practical uses, these both are related. I don't think we have enough time to do this. I'll pick this up maybe next week or after that. So yeah, any other questions? The hardest part to it's very hard to teach when no one is asking questions, because I don't know whether it's clear, what I'm teaching is clear or not. And I mean, lectures needs to be interactive. The students needs to ask questions. Then only the lecturer get a feeling that whether he's teaching right, whether there's any issues, shortcomings in his teaching. So I really appreciate if you can ask questions. That is actually one of the key differences, like from when comparing students, like the experience that I have with foreign students is that they ask so many questions. Even the tiniest one, they don't understand, they ask. Probably there's one reason could be that they are paying for the tuition, right? So they are paying for the degrees and all. So maybe that's one of the reasons that they want to get the maximum out of it, and you are getting it free. Probably that could be one reason, I don't know. So somehow, if you can, improve your public speaking peers, and if you can basically ask question, and this lesson can be an interactive one, then it will be much better for both you and me. Okay, so if you don't have any questions, Saranga, do you have another lecture after this? 2:30, after 2:30? Bandara, Saranga.
Yes, sir.
Do you have another lecture after 2:30?
No, sir.
Okay, so can I get maybe 10-15 minutes after 2:30? I mean,
Okay, sir.
yeah, so that, let's move on to doubly linked list, right? So there's so much to explain. The thing is that I'm trying to go very slow. I'm trying to, so as you can see, I have explained using the presentations, and I have already again explained during the code. So I'm basically explaining it twice. Each function I'm explaining twice, so that you can understand. If there is at least a student who don't understand, who don't who is not familiar with computing and software engineering. I mean, there could be students like, because you are from different disciplines, right? Some of you may be doing power, some of you may be doing electrical communications, or may not have the same background or the same expertise as someone of a software engineering discipline. So that's why I'm explaining it twice. So that I'm taking a little bit more time. So we are running out of time. So that's why I asked you for 15 more minutes. Hope that's okay with you. Yeah. So double linked list. So am I recording this? Yeah. Doubly linked list, the main difference, as you can see over here, is in doubly linked list, we have two links, right? So earlier in single linked list, so earlier in single linked list, when you take a node, there was only one link. This part is where the data is, right? And then this is the link, right? That is how a node look like in single linked list. Whereas in double linked list, as you see over here, right? If you take a node, there are two links. One is linking to the next node, another link that is linking to the previous node. So two links, right? So how the node class look like is, so there will be a value, let's say element, and there will be a pointer pointing to the next node. There will be a pointer pointing to the previous node, right? And how a class look like is quite same. There's nothing different over here. It's same as a single linked list. Only difference is actually over here, the addition of this link. So that's the difference between single and double. Right. So let's see what are the differences. I'm not going to explain everything from the beginning. I'm only going to explain the differences, because otherwise we won't be having time to complete the things. So the difference between insert first function of single linked list and the insert first function of double linked list is over here. Yeah, the difference is actually we start with the same. So what we're going to do is we are going to insert this node, right? So we're going to insert this node to the beginning of over here, right? To the beginning of this list. So pretty much the same. The first things are pretty much same. So we check whether the head is null. So if it is null, what we need to do is, so before that we need to create a node, right? So this is the node. We create a node with a temp pointer, and if the list is empty, we just have to, so this is the temp node, right? So we just have to point the both head and tail, right, to this link, this node. Sorry, this node should have two links. So the one previous link and one next link. So that's the first thing. And if the list is not empty, so that means the list is something like this, right? So the list is something like this. Probably there are a couple of nodes. What we can do is similar to the similar to what we have done with single linked list. The first thing we need to do is we need to connect this next link of the temp to the head, right? How we do that is temp.next equal head, right? Then the new thing that we're gonna do over here is we need to connect the previous link of the head, right? So let me take another color. So now each node consists of two links, right? So the head node also consists of a link that is, there will be a previous link, right? So we need to connect this one to this guy, right? So head dot next, sorry, head dot previous will be temp, correct? So we are connecting this guy, this link to this guy, and then we need to shift the head to temp, right? This one, correct? And then increase the size. Is this clear? Dharmaratna 3568. Is this clear?
Yes, sir.
Okay. Okay, the next thing, insert last. So insert last means we are going to insert a node to the end of the list. How much time do we have? Should be enough. Yeah. So the same thing, create a node. If it is empty, assign both head and tail to it. If it is not empty, that's where we need to discuss. So if it is not empty, the first thing we need to do, we need to connect the tail dot next to the new node, tail dot next. That's the first thing we need to do. And before moving the tail over to here, we need to fix the previous link of the temp. That means the node that we have created. We need to connect the previous link to this guy. That one, temp dot previous. You need to connect it to tail, and then finally we need to shift the tail to the temp. Correct? Understood? Kumara 3641 Kumara. Is this
Yes,
clear?
sir. Yes, sir.
Okay. The third one, which is insert at, right? So insert at, pretty much the same thing in terms of right, the position wise. I'm not going to explain this again. So position, we need to check whether it is in between 0 and size. Why the equal sign is not here? Let me check. I think the equal sign should be there, right? Earlier it was there, right? Yeah, I think there's a mistake from my part, probably. The equal sign should be there, right? 0, 1, 2, 3, 4. Sorry, yeah. Here this is not delete, right? Equal sign shouldn't be there. This is not delete. This is the insert, right? So the equal sign should not be there. Let me delete it. Yeah, so the equal sign shouldn't be there because this is insert, right? I got that messed up. Yeah, so equal sign shouldn't be there because this is insert. Now, if I explain again why the equal sign shouldn't be there. So how our indexes starts is 0, 1, let's say 2, 3, right? So now if someone is asking us to insert a node before 0, that means -1 or something, that we can't do, right? So so that's why this part is there. But if someone is asking us to insert a node at 4th position, now the size of this linked list is 4, right? The size is 4. So if someone is asking us to insert a node at 4th position, that means he is asking us to insert a node at the end. So that's why the equal sign is not here, right? So that's why the equal sign is not there. Okay, and if the position is exactly equal to 0, we basically call the first insert first function. And now, as I mentioned, if position is exactly equal to size, we call the insert last function. Whereas if it is not the case, that means someone is asking us to insert the node at a middle intermediate node at a middle position. So the first thing we need to do, we first need to create the node, right? So that's over here. And again, we need a current pointer, and see, current pointer, we need a current pointer, and we need to shift it from head all the way until, I mean, if he is asking us to insert it over here, so we need to shift it until over here, right? So the current pointer need to stop at, so in this case, he is asking us to insert a node at the 2nd position, right? 2nd position, the position is 2nd, right? So the current pointer needs to go until over here, right? 2 - 1, correct? Yeah. So then let's see how we're going to insert then this node to this link. Yeah, the couple of things you need to do. So we first need to link this. There are 2 links for each node. Now there are 2 links. The first thing we need to do, we need to link this to this guy, correct? First thing. And the second thing we can do, we can link this to this guy. Second thing, the step 2, and the third step could be the next pointer of this guy. We can connect it to here. The third step, and the previous pointer of this guy, we can connect it to this, the 4th step. Correct? So these are the steps that we need to take. So let's see what are the corresponding codes. Yeah, this is the first one, temp.next. Temp is this guy, right? Temp is this one. Let me take another color. Yeah, so temp is that one. Temp.next is this link, right? Temp.next is this link. So we're going to link it to current.next. Current is this guy, right? Current.next. So at the moment, current.next is this link, right? So current.next equal temp.next. The next thing we need to do, temp.previous. Temp.previous is this link. So we need to link it to current. Correct? The third step, current.next. So current is this guy. Current.next, we need to, which is currently at this link, we need to connect it to over here, temp. The 4th step, which is a little tricky one. Now, can someone tell me why we have done it like this? Temp.next, why have we done it like this? Can someone tell me? There are too many links over here. I'll draw it again. So let me draw it again. So now what we did first is we connected this one, right? That's the first thing. The next thing we did, the previous link of the temp, we connected it to this guy, right? That's the second thing, right? still now, let me draw it with a different color. Still this link. Now he's the current. Is the current. Current dot next is still pointing to this node, right? Now what we did next was current dot next. We basically deleted this link, and current dot next we fix it to we redirected this to temp, right? This is the temp, correct? Now we lost this link, right? We lost this link. We no longer have access to this node, right? Because we lost this link. We redirected it over here. Now, how do we make this connection? Temp.next. How we do that is, sorry, not temp.next. Let me delete it. Please tell me if I am doing something wrong, right? So what is left was we need to make this connection. This one, right? Previous connection of this node, we have to link it to temp. How do we do that? Because now we lost this. So the option is, what we can do is, I mean, the problem was how do we access this node? Because we lost this, right? So how do we do that is, we can write it as temp.next. Temp.next is how with temp.next we are accessing this node. Temp.next previous, this link, temp.next previous equal temp. Is this clear? This might be a little tricky, but I hope you understood it. Is this clear? 3646 Kumar Singh, is this clear?
Yes, sir.
Okay, good. So yeah, so we'll quickly go through the delete operations. We have 10 more minutes. I want to take the last 15 minutes for something else. So let's quickly go through the delete operation. So delete first. I'm not going to explain all the details. So delete first. What we need to first do, check whether the list is empty. Now we do that. We check whether head is exactly equal to null. Then we output a message saying empty list. And if it is not, so I hope this is clear to you. I mean, we have done this very recently, right? Today itself. So we create the temp pointer and we assign it to head. And the first thing we need to do, we check whether the size is exactly equal to 1. That means there's only one node. So we simply delete the temp and assign both head and tail to null. If it is not the case, that means it's something like this. The link is something like this. So it is quite same. So we take the head, we assign, we basically shift the head to this node, right? However, remember to do this. Head now head is over here, right? Now head is over here. There is a link, previous link, right? That one we need to assign it to null. At the moment it is assigned to this node, right? Which is not yet deleted. Now before deleting this guy, we need to assign it to null. So that's what happened here. And then finally we delete this guy. All right, clear? I'll go a little faster because we need to complete them. So the next one is delete last. Yeah. So this is where I think someone asked me this right earlier, why can't we, now this is the code from single linked list. So what you see over here is the code from single linked list, where if you want to delete the last node, right? If you want to delete the last node, this one, if you want to delete this guy, we first need to create the current pointer and shift it all the way until over here, then do the deletion, right? Now we don't need to do that because now we have a previous link, right? So what we can, instead of doing all these, so instead of creating a current pointer and moving it all the way to this over here, right? Instead of doing all that, what we can do is simply, instead of, let me write it precisely. So instead of doing all these, we can simply move the tail we can simply move tail from here to over here, right? So we no longer need to have a current pointer and move it all the way here. We can simply move tail from over here to here, one node up, and then we just need to do tail dot next. Now tail is over here now, right? Tail is now over here. Tail dot next is this guy. That one we simply assign it to null, right? And then we can delete this node, right? Is this clear? The person who asked me this, I think Banda, no, not Banda. Is it Banda? I don't remember. Is it clear? Lakshan, is it?
Yes, sir.
Yeah. Is it clear now?
Yes, sir. Yes.
The thing that you suggested, we can do it with doubly linked list, right? Okay. Yeah, delete at the last thing, right? The last thing, yeah. Yeah. So delete at, let's see how it is done. The same thing. I'm not going to explain this again. So check the position. If position is equal to 0, delete. I call the delete first function. If it is the last node, call delete last function. And else, okay, else that means he's asking us to delete a node at a middle point. So for this, we still need this current. So we start the current over here and shift it all the way up till over here, right? Yeah, and oh yeah, so there are a couple of ways you can do this. What I have done over here is, instead of moving the current pointer to one node up, I have actually moved it all the way to the node that we are going to be deleting, right? So there are a couple of ways. So what I have done is like this. So I have moved it because now here is not position -1, is position, right? So that the current will end up over here, right? So then I have created a temp, right? Temp. Okay. Yeah, I have created a temp, and then what we need to do now is, now since we are going to delete this guy, we need to rearrange this link. So what we can do is, so we have to rearrange this one like this, right? We have to rearrange this one like this. So basically we need to redirect the shift the links that were previously pointing to the temp, right? So the first thing we can do is, now current is over here, right? Current is over here. Current dot previous, that means this link, right? Current dot previous dot next. So current dot previous is this node, right? With current dot previous, we are basically accessing this node, and next link of that node, that means this link, this one we'll redirect it to temp dot next. Temp dot next is this guy, right? So what we have basically done is this is what we have done, right? Let me draw it again. Not clear, right? So this is how it was. So first thing we have done is this one. Current position, current is this guy. Current dot previous, that means this guy. Dot next is we have linked it to this one. Current dot next is this guy, right? Current dot next previous, that means this link. That one we have linked it to temp dot previous, right? We have linked it over here. So that's the two things that we need to do. Then we can delete this one. Understood? Any questions? Any questions? This one I'm not going to go through. There are a couple of other methods that you will find with single linked list, even with double linked list. You can find nodes. I think I have explained one, right? So you can find nodes. You can find the first node with a given element. Earlier, what I explained was the search operation where we are going to be searching all the nodes with the given element. So this method is actually, you can go through this later, is to find the first node with the given element, right? So you can go through this later. Yeah, that's about it. So is this clear? This might be a little tricky. Is this clear? In the exam, I might be asking some questions like this. I'm going to give you hints. So the students who, I'm going to stop recording.